Okay, hello everyone. This is Kwan. This is my picture because it is an online course, so you may have no idea about what it looks like. So this is me. So today I will give a presentation of two articles. The first one is conceptual modeling for simulation. The second one is interoperability between WiMAX and the broadband mobile space network. I will focus more on the first article because it is highly related to this course. And for the second one, it is academic papers, so I may focus more just on the structure of how the author read the article. So first, what is conceptual modeling? Conceptual modeling is about abstracting a model from a real or proposed system. It means that it is not a real system. It is an abstracting system. It can be a logical model. It can be a mathematical model. It can be a scientific model. Just for several examples, like the disease graph model, the traffic light solution model, or like the example in this article, assembling plant model. There are four main components of the model. The first one, objective. It is about what's the project about, or the purpose of the project. The second one is input. It is the elements of the model which can be changed to affect the result. Third one, output. It is a result or a report which is generated from the model. The last one is the model content. It is consists of the components that are represented in the model and their interconnection. Yeah, I would like to give an example of what is conceptual modeling about, particularly for simulation. There's a software I used for modeling simulation. The name is called NetLogo. So for this model, it focuses on the question that how the numbers of cars and the speed limit affect on the average speed of cars. So this will be the object. The number of cars here and other factors like speed limit will be the input. The number of stop cars, the average speed of cars, the average waiting time for cars will be the output. The rules let's see in this way. Like when it's the red light, the car has to stop. If it is a green light, the car can go. If there's another car in front of the car has to stop. And if there's no cars in front, the car can go. This can be the content, the model content, and also the cars, the traffic lights on the street. So let's see how this model runs. Like when there's 100 cars on the street, and it will tell you the average speed of cars. So if you change the car numbers to 200, anyway, just 199. So 199. Like the setup, we can see there are more cars on the street. and the average speed will be changed. Okay, that is what a model simulation model looks like. There are three requirements of the conceptual model. The first one is describing four main components. It means that in the model you have to have the four main components: the object, the input, the output, and the model content, which as I showed in that traffic model. And the second requirement is that it has to be as simple as possible. So as you can see in the traffic model, there's no people walking on the street, no emergency cars, no accident on the street. And also the last one is the validity and the credibility. Basically, they are the same thing from different aspects, saying that the data, the factor should be real. So if I put a speed limit, like in that traffic model, if I put a speed limit to, let's say, 300 miles per hour, it could not be real. The result generated from the model neither will be real. So in the rest of these papers, the author also discussed something about the definitions of the conceptual modeling, which I did not cover in this presentation because you can get it anytime online. Just Google it or go to Wiki. The second article is interoperability between WiMAX and the broadband mobile space network. I will focus on how the writer wrote this article and how the structure looks like. So at the very beginning of the article, the author gave a general background about what the WiMAX is. As we know, that is a large area cover wireless network. Yeah, I always said that, like, if you know that in the building the wireless network is Wi-Fi, so in the city if there's a access point which have the coverage of a large area, for example the city or the small town or a valley, it is a WiMAX. For reducing the cost and improving the performance and the coverage of the WiMAX, people would like to connect the WiMAX. So in this article, it discusses the possibility of the possibility of connect the WiMAX. There are 5 levels of integration between satellite and the terrestrial system. Because we know if we want to connect the WiMAX, we have to use the satellite. The first one is geographical. The second one is the services. The third one is the network. The fourth one is the equipment. The last one is the system. In this case, only the first level is related. So the author generated 3 scenarios. Satellite link as a backbone among WiMAX cells, satellite extending WiMAX coverage, satellite link as a coverage gap filter. And in each scenario, the writer gave different structures or say architectures of how it works. And following that, the author gave a feasibility analysis of whether it is possible to do that, and in which kind of architecture it is possible. And also because the WiMAX or the satellite, this kind of wireless technology, it will focus on the signal strength. Or say it is a real key factor. So the author also gave the link bounded analysis. After that, the author generates the conclusion that a large gain in the satellite transceiver is necessary, and the high altitude platform as a repeater for WiMAX is necessary. Yeah, that's what I want to bring to the table for this article. That's all. Thank you very much. If you have any questions, you can send me an email at quzhou@syr.edu, or you can leave me a message on Blackboard. Thank you very much. Have a good night.